welcome to the Calculus C section. In this section we'll be discussing curves defined by parametric equations. In prior we have solely discussed functions as the following: y equals f of x and x equals h of y. However, these two functions do not account for or can easily be manipulated in calculus. So let's say we had a circle and the equation is x squared plus y squared equals r squared. So if we wanted to look at this circle graphically or represent it with our functions, we would say that y is equal to r minus x squared, r squared minus x squared, my apologies, and this would only give us the top of the circle. But we could say, okay, let's say we want to do y is equal to negative r squared minus x squared. Well, now this only gives us the bottom. And as you can probably assume, if we say x equals r squared minus y squared, well, this is only the right side, and the negative form of this would be the left side. So what curves defined by parametric equations really do is, rather than defining everything in terms of y of x or vice versa, we define things with three variables. Our third variable is a parameter that is generally specified by t. So we say x is equal to f of t and y is equal to g of t. So now, having a function, we know that x of y is equal to f of t comma g of t. And now this allows us to account for the entirety of a circle per se. So we would have not only the top but also the bottom. We would not have only the right side but also the left side. So this allows us to represent the locate. Let's say we wanted to say a point, and we're going to use variables here. At the point xy, okay, we want to throw a tennis ball off a cliff. So this point right here, xy, represents the location of the tennis ball at the time in the air that it's representing. And the parametric curve will represent the trace of the ball at all of the locations. So if we say at the f of t, let's say f of 2, g of 2 would represent the time the ball is at 2 seconds. But our entire parametric curve would represent the path that the ball took from 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. So I hope that little demographic helped and you are better understanding curves defined by parametric equations.